Number 3. Before we do number 3, I just have to point out this is the last video. It's the last one. Okay. So find the area of the region between the graphs of f of x equals 3x cubed minus x squared minus 10x and g of x equals negative x squared plus 2x. So for sure we need to find the points of intersection. So we need to do 3x cubed minus x squared plus, minus 10x equals negative x squared plus 2x. So we need to move everything over to the same side. So I'm going to do plus x squared and minus 2x. So plus x squared minus 2x. So I've got 3x cubed minus 12x equals 0. So let's factor out a 3. And let's go ahead and factor out an x. So 3x times, and then x squared minus 4 equals 0. Let's factor a little bit more. 3x times x plus 2, x minus 2 equals 0. So our points of intersection occur at x equals 0, x equals negative 2, and x equals 2. So what that means is, if we're just looking at x values, we have these 3 points of intersection. We also know quite a bit about what these graphs look like because f is a cubic function, so it does something like this. And then g is a quadratic function with a negative coefficient in front of the x squared. So it's a parabola whose graph opens down. And now we also know that these two curves intersect in 3 points, and so they have to intersect in some way kind of like this. And so the 3 points of intersection, and of course my picture is not to scale, but the 3 points of intersection are something like that. And so the two regions that we'll want to think about are this region right here and this region right there. And so from negative 2 to 0, we need to integrate. And from 0 to 2, we need to integrate. And to do that, let's go ahead and figure out which function is on top. We can do that by plugging stuff in. So I'm going to test negative 1, and I'm going to test positive 1. So I'm going to do f of negative 1, get negative 3 minus 1 plus 10. So I got 6. And I'm going to do g of negative 1 and get negative 1 minus 2, which is negative 3. So f is on top from negative 2 to 0. And it's a good guess, but definitely not for sure, that maybe g is going to be on top on the other part. So let's go ahead and do f of 1. Do 3 minus 1 minus 10. And then, let's see, 3 minus 1 minus 10. So 3 minus 11 is negative 8. And then g of 1, I'm going to get negative 1 plus 2, I get 1. And so on this portion, g is on top. Now, if we didn't feel like keeping track of which function was on top, we could integrate f minus g on both of the sections and then just fix the negative if we came out with a negative area. But it is important to split up your interval, negative 2 to 2, split it up into 2 chunks. So we'll talk more about that in a moment. So let's go ahead and work out these definite integrals. So we need to do the definite integral from -2 to 0 of f of x minus g of x dx. And when I worked out f of x minus g of x, I got 3x cubed minus 12x. And so when I anti-differentiate, I get 3/4 x to the 4th minus, and then 6x squared, evaluated at 0 and -2. So get 0 minus, and then 3/4 times -2 raised to the 4th power is 16, minus, and then 6 times 4 is 24. Okay, so let's see, that works out to be -12 minus 24, which works out to be 12. Okay. On the second portion, I need to do definite integral from 0 to 2 of g of x minus f of x, which is going to be the definite integral from 0 to 2 of 12x minus 3x cubed dx. So I get 6x squared minus 3/4 x to the 4th, plug in 2, plug in 0. So now when I plug in 2, I get 24 minus, and then 12. So I get 12. So my total area is 12 units plus another 12 units, which is 24. So that's the total area between the two curves. Now, if you didn't want to take the time to figure out which function was actually on top on each portion, you could integrate the same one both times. So for the second definite integral, for example, you can do the definite integral from 0 to 2 of f of x minus g of x dx, and then take the absolute value of the answer that you get instead. So the important part is that you remember to break up your original domain of integration using the points of intersection. And after you've done that and done it carefully, you can integrate the difference, f minus g or g minus f, as long as you remember to disregard the negative at the end. So if you did this way, you would take the absolute value of -12 and get 12 here. So you can do this similarly to how we were doing the total area between the curve and the x-axis. If you make sure that you break things up carefully and then disregard negatives via taking absolute value if needed.